Welcome back to our Scala to Spark lessons. We are continuing with working with data frame, various transformations, and if you want to change a setting, for example, you want to change case sensitivity, there is a setting. Our book gives us SQL instructions, but I will show you how to do this is in using Scala syntax, right? So let's start our new book, a new object. Right, so object day 22, more, I guess, more transformations, right? Column, more column transformations, and of course extends app, right? And this will be again something like this: print line, day chapter 5, right? And we have column operations, right? Some more filtering, column, row operations, right? Something like that. Okay, so again, as we saw before, we have always need this new Spark instance, right? So something like this, right, would work. And we would like to set a setting. So again, let's run it, basic Spark. And again, we'll fire up the Spark engine, and let's see if everything works. Looks okay. Okay, so let's wait for the shutdown. On everything works, 5 partitions. So yes, setting, as we saw in our utilities, right? We use this this syntax, right? So if you want to do it, it should work, right? So Spark session, it's not Spark, but you say Spark, right? Gets quicker, right? Spark conference set. We don't have partition count, right? So of course we're going to say true, right? And of course here we need the right name of the setting, so we're going to use this one here, right? Case sensitive. Of course these instructions are slightly old, so maybe this won't work anymore. Let's try it. Yeah, let's see if this works. This will set SQL sensitivity to be case sensitive, right? Again, right? So sensitive. Let's see if this works. Maybe such a property does not exist anymore. Again, remember, let's wait for our warning. Yeah, everything works. So it again. So from now on, the queries, the SQL queries would be case sensitive, right? Yeah, would be case sensitive. So there are many options. You can read up how many configurations Spark 3.30 guide. There's many. There are all kinds of operations. So there are many configuration settings you can set at runtime using the above syntax. Right? There's quite a few of them, right? There's also ways to do it in a file, right? Because of course it gets tiresome if you have set maybe 10 different settings, right? Even if the syntax is not hard to understand, you still get tiresome. Okay, so let's moving on. We're gonna remove again. I promised dropping columns, so let's do that, right? We had our long name column, right? Let's get that. So we can drop. Of course, in order to drop, we need to read it, right? We need to read it. There it is. Right, or transformation or flight, right? We need this part here, right? And we need to read it here, right? 22, right? On there's our 22 right here. On yes, and of course we have our flight path, right? And so we can drop some columns, right? Again, so I'll show you an example. So df drop, right? Drop columns, I believe it's called drop, right? Drop, and we can do multiple columns. So of course we can first print what the names are, right? So df show, right? And 5, right? And then we can do df drop column names, right? It's going to be multiple columns, so we have, let's say, drop destination country. What was it called? I always forget. Okay, so we'll just get these two, since I'm lazy, right? So I will do this, right? And this will show only show 5, right? It will, you know what, and it will show only will show data frame with the 2 columns below dropped. Again, if you wanted to save it, you would save this separately. So this is if you want to save this result, this data frame, to some other data frame, right? You would do it at this point here, before showing. And of course, when you show it, you actually run the instruction. Again, remember in Spark, these instructions, drop, column, instructions from previous lesson, again, they are combined later on. So when you do it, so it's like a, I would say, Schrödinger's cat. I can't spell it. When you're not sure what's going to happen, right? Only when you do actually call it, right? The instructions will be executed by the Spark engine, right? You perform the instructions, and then you actually see the result here, right? So let's take a look. Drop, and yes, we are left with count. We had destination country, origin country name. We are left with count, right? This part here and this point. Again, this is data frame up to here when you do a drop, right? Because drop returns a data frame, just like with column. Okay, so that's how we delete the columns, right? Right. So we could do also by select, right? We could use select, of course, as well, right? Why? Well, because you can. So this is negative. So there is why we could do it by select, right? Right. So something like this. So we can do it positively. So we can to iterate we can use select to get columns we want, or we can use drop to remove columns we do not want, right? That's not, so depends what you need, right? You can go from one end or other end, or combine it, right? You can have everything, maybe combine. Okay, so well, now we get to some harder stuff, of course, changing data type, right? So if you want to change a data type, you can cast it, and we can create a new column. So this will be a new column. Well, cast to a long data type. Let's take a look, because I think count was originally, let's see, our data df print schema. Let's say, take a look. Right, I think it's not, it's string, I believe, right? I believe it's string. Let's see, because unless we specified schema header again, so the inference engine actually it's long. Okay, it's long already. It's long, and what is this one? It is already long. Okay, well, it actually is long in here. It is long. So let's do integer, right? So here it is already long. So well, in our case, our account is already long, right? So that's fine. But we can cast, so we will cast to integer, you know, so half the size of long, right? But still, you know, still wholesome, but still whole, right? Whole, right? You know, not floating, right? So that's a possibility. Or maybe we can do double. Let's try this. Okay, now let's cast it to integer. Okay, let's cast to integer, right? So half the size of long, and also let's cast to double, right? I'm always so double, which is floating point, right? Just double precision of regular float. Okay, let's do that. So so df, right, this is column, right, and we have a cast So casting names will be, this looks like they are going to be the Scala. No, you don't have to use the typing, right? So as long. So let's try this. So this will be count to, count long. But of course here, right? That would be pointless because first of all you have to import column, right? But this cast is pointless. Why? Because show 5, right? But this is pointless, so I will do int. I believe it's int. Let's take a look. Let's to int, right? So one column, and let's do one more. Count 3. Count 3 column count again. Will cast to double, right? Let's do double. So show 5. Let's see what happens. We'll see. I didn't check the documentation, so I'm sort of guessing the types. So I might need to run this again. Let's see if we have an exception. Oh, it worked perfectly. Right? So count 2. Of course, you can say, okay, what's the difference between this column and this column? Well, I'll show you. Right? Instead of showing here, right, we have a df. With 3 counts, right? Right. Of course, it's a val. So I'll show you, of course, df with 3 counts. Show, right? 5, right? That's no big deal. But so df with counts, 3 counts, print schema, right? You'll see that is actually so. This takes again. So when would you use these casts? Well, first of all, of course, most often you will cast. Of course, most often the cast would be from string to int or double, right? That would be most common, most common one, right? To long, int, long or double, right? Again, why isn't float used? I mean, you could use float, but because it's less precise, you don't use it much. So it's for saving space, right? It's for saving space in your and locally, for example, right? Because of course. The double again takes more space, right? Again, if you don't need the extra numbers, again, so what's the difference? Again, remember, double can go to up to 18 sextillion, I believe, roughly, right? A regular integer goes up to 4 billion, right? Or 2 billion if you count the sign. So let's see. Let's print the schema in this case. So we come up with a new name for the column, and we take some existing column, we cast it to, so long integer double. Okay, like I said, again, in this case I'm right. So again, so the most common is because why? Because of course, why reason? Reason being that you want to perform some numeric calculations on that column, right? So you need a numeric, of course, right? But sometimes you also want to change the types between these different data types. Okay, let's move on. So now we get to the filtering. I showed you a little bit of filtering, right? So we need an expression that's true or false. That's going to be our filter, right? So we create either a string or using some column manipulation. So we use where or filter. They will do similar, right? We'll use where. Filter will also we'll use where because it looks very similar to SQL, right? So filtering row, right? Yeah, so this is where we get to the meat of this today, right? So we will want to, right? So these will be exactly the same, right? And let's show both. Where count is less than 2. No, I will do where count is okay. Let's do that first. Right, so this is so where syntax is more SQL like, so that's why it's more used. So this is this less used, right? But this is more common, more common, right? Due to being similar SQL syntax. So we'll see all the counts with one, right? Just a single flight, right? Single flights. Let's do 5. I want to see what the flights look like. Okay, 1. Croatia, Singapore, Gibraltar, even flight to Gibraltar. Okay, great. On one flight from Malta to United States. It's kind of strange. Some of these United States, Moldova, kind of strange. It's a few flights. Okay, but this is from 2015. Okay, so we'll see maybe an example. See how to do multiple filters, right? Right. By the way, your instinct, right? You might want to put multiple filters because that's, of course, we have been working with regular SQL. So this is an important point, right? I've been telling you this for a few lessons already, that Spark Engine decides best how to do the queries. So you don't really you say, okay, roughly what you need done, and Spark will figure this out. So you don't want to, I mean, you could do this, right? Let's say you want to, so you could do this, right? Let's say, right, so this is count, and I think this, you can do this, right? Count, let's say less than 10, right? But more than, let's say more than 5. I don't know, it should work. I'm just guessing it. Right, let's try this. I think this technically works, but it's not the best use of, like the book says, you don't really want to use it. Oh, there's one, United States, Paraguay. So this works, but better to chain multiple filters for optimization. So how would we do this with multiple filters? We do this df, right, where count equals 5, right? And of course we can do it again where I think it also looks nicer too. Again, that's, again, you think, okay, silly, right, less than 10, right? Because you can easily modify these, right? Again, one line to this is very typical, right? So where these are all data frames, right? Data frame, data set. Well, technically data set, right? But of course, it comes up again to a regular data frame. Again, data set of rows, right? But right, rows giving SQL expression, right? So in fact, actually, it does use exact SQL syntax, right? Right. So this is prefer multiple chains, right? Yeah, it still gives you United States and Paraguay. Okay, great. Now let's move on. So that's first filtering, right? So this would be possible, right? So we were, right? This is again same type of query, right? You do it, and you have multiple, so column count less than 2, where origin country is not equal to Croatia. Notice this not equal, right? So this is also possible. Again, right? We can do this, right? So this is less than 2, but it's not Croatia, right? So origin is not Croatia, right? So again, I like to do this, right? So let's get 3 countries where origin is not Croatia. I don't know if it's why you want to do this kind of query, but yeah, you can. So 2 multiple filters, right? So column count less than 2, and where origin country is not equal to Croatia. So this is the only thing is why you have extra this. Could we skip this? That's a good question, because it's technically this is regular SQL syntax, right? This extra inequality. Let's try this. But it's actually used to be, you have to write like this. we're doing good. Yes, so there's no Croatia involved. Was there Croatia before? Yes, there was Croatia here. Right, so there's no Croatia anymore. Okay, good. So you have multiple where, and you get the use multiple fillers. So we'll be using quite a few of these where conditions. Okay, so getting unique rows, right? You want to get distinct values, right? So we use distinct method, right? So you say you select, right? So let's get unique origin, unique origins. Of course, only rows which contain unique origin countries. But of course, here we are gonna do count, right? Count is actually gonna count how many of these are, right? So something like this, right? You want to get unique values. So this will be a number, right? Should be 256. Number of unique count, unique actually we get both, right? We count both. So right, so this actually do two, we get origin, country name, destination name. So we want the unique combinations, right, of these two rows, right? So if I wanted only just by one, it will be different, obviously, right? So count unique flights, right? I believe, or unique. Let's take a look. 256, I think it was. Let's see. First of all, let's go big is our data set, right? Yeah, 256. Of course, this will be exactly, but this will be different, right? This will be different. Should be 125, right? Because we have different, you know, both directions, right? So so let's try this one. Select, right? Should be 256. I'll just print it, right? So this, well, you'll see this again is a number, right? This will be count returns, of course, a long, right? This is a long number, right? We have print line, number of flights, number of unique flights equals count. Oh, sorry, Control Z, count unique flights, right? Nothing too complicated, right? So this will be 256. Of course, again, since I'm getting lazy, if I do only this, right? So print line, we don't need the variable. We could just do, just do it directly. Print line, as origin name, right? And count, right? Distinct count, right? This should be less. Should be 125. So unique, distinct origin countries, right? Again, there's I don't think there's 256 countries in the world, right? So let's take a look at these two. So here we have all of them, right? Distinct, because, right? So I'm pretty sure they're all distinct, all 255. Maybe there's one. I think they're all distinct, right? So 256. So 125 should be the answer. Let's take a look. Origin. So far so good. Yes. So unique flights to number of origin countries is 125. Okay. So we can continue. So random samples, right? You just want to know something, right? You have a large data set, right? You can actually say how much data you want out, right? So and you can set some extra settings. This might be useful when you're doing some machine learning, when you need you want to basically get this idea of what the data entails, right? Again, as you know from statistics, sometimes it's enough as low as 30 rows or records can be enough to make statistically significant measurements, right? So you don't need whole 100 million rows, right, of data. Maybe 100 is enough. So how do you do it? You have, of course, you can do it by hand, but this is provided by Spark, right? So what's a seed? So if you set a specific seed, right, it will be it will be give you specific sample. It should work exactly the same way. So this would be it should be a random seed if you want to be don't care about the specific data, specific sample, right? Again, sometimes again, if you're testing things, it seems kind of silly. Why do you want a specific sample, right? But it makes it easier to test things, right? It's random again, so it's like it's like you glue the random dice, right? It's like the joke about the Dilbert random number, right? Or maybe even XKCD random number, right? So basically, you sort of glue this 4, right? You say, okay, you did you did it randomly, but then it will always throw the dice the same way each time you run the program. So this is random. Sorry, Control Z. Random samples, right? You want to get some random sampling. So of course these we can supply directly, right? And let's take a look, right? So count, right? Right, so we'll have, this will be sample, right? Replace, this should be how many? Let's do sample 1, right? So 10%, right? Should be, so here we should be about 25 or 26 print line. My sample, well, we have sample, right? And then we can do some ideas. Again. Replacement. So what does it mean here? So this replacement means that do we have is replacement or not? It's again, I always keep reversing them. What does it mean with replacement? Sample with replacement. Sorry, not like this. Sample, right? Right. It's a good question. Right. Spark. Right. So, uniqueness, right? Right. So yeah, okay, yeah. So if you set it to false, usually you want false. You usually want false, right? Meaning, if you don't set it, if you set it to true, right? So with replacement, if you set with replacement true, that means you will be putting your sample, your row sampled back into the cookie jar, right? So usually you do not want to draw the same ticket more than once, right? So usually you set it false, okay? But of course this is just a boolean, so the actual work happens here. So df sample, right? Let's see it. Df sample show 10. It should always be the same thing, and of course you should see a number, right? The print line. We got df sample count samples. Okay, let's take a look at our code. So how are we doing? Let's see. We got 34 samples. That's a good question, actually. 10%, but we had, well, how many rows did we have originally? I didn't even check. We had 256 rows. So the sampling, well, it's interesting, right? Well, first of all, let's check. It's not, certainly, you would expect 26. Well, turns out this fraction, right, is not really that hard, right? Fraction range, oh yeah, so 1.0, right, it's not exactly, right, you see? It's not guaranteed exactly, the fraction is not guaranteed, it's close, but it's not really that close, right? I got 30 in 34 samples. I would expect 26, so it's pretty big variation. So again, so now let's check. I had my seed 5, right? So this guarantees, so static seed should guarantee same sample each time, right? Let's check. This is relatively surprising that, yeah, it's not the fraction, sampling is not exact, right? Why? You say, okay, you have only because we only have 256. However, this is meant to work across like 100 million, right? Again, we got exactly the same data, exact same sampling. So if I do sampling randomly, so I will do Control D, right? So let's do random sample. So random int, right? Next int, right? I believe something, I don't know. Yeah. Scala utility random is fine, right? Remember, so this is what uniformly distributed, right? So up to 2 billion, so right, so here, so up to 4 billion different integers, right? So that's, again, let's try it now. Right, so static seed, right? It could be anything, right? 42, whatever you want, right? Here you have a random seed, right? Again, of course, it's pseudo-random, of course, not completely random, but for practical purposes would be good enough. So this time we should expect we'll have a different seed, and we'll have different fraction, meaning it won't be 30. It should not be 34. Let's take a look. Yeah, you see, you got 30 samples this time. So 10% is just a rough estimate, right? You will get close, but maybe again, so it was off by, we had 34, that's about almost we had, could be off even more, right? Could be for smaller data sets such as ours, the fraction could come out to be 0.9 or 1.3 or something, or some, would come out to be, could be more or less. We could maybe do a little sampling loop, right? Get a new seed, right? Do a loop on run. Maybe we need to actually create a function. It would be nice to create a function. So this would be, maybe we'll do this after the break, and when we do the exercise, right? This could be a nice little exercise to check if we can check the sampling, the fraction again. So that's something to be aware of. It's interesting. It's useful, right? But it's not guaranteed to provide the exact, right? So this is note. So this is, again, usually it's good enough, right? If you have a big data set, it will be, the more data you have, the more precise it actually will get. For small, it doesn't work, right? So note, right? So that's something to keep in mind. Okay, but I think you got the idea how it works. Now, we get this replaced. So splits. So again, if you're doing some machine learning or something else, some testing, right? It might be nice to split the data to, again, like we did training and validation test sets, right? So we can use it as similar how we did sampling, something similar. We'll get 2 data frames, right? Again, we'll use seed again, right? Of course, if you don't specify proportion, that's of 1, they will be normalized. Okay, so let's take a look. So random split, right? Seed, of course, is our random seed, right? Right, and let's take a look, or let's look at our counts, right? Let's take a look at our counts. Data frames. So data frames will be array of data frames. So we'll have multiple arrays. This is array of data frames, array of data set. Okay, so technically array of data sets. So technically we get array of data set row, right, which is same as array data frame, right? Again, same thing, right? Same thing. Again, remember Scala, Spark uses this data set row on the data frame interchangeably in many places. You can run the same methods and everything. So, right, so we can check, right? So we have 2 split array of, so these are the 25% and 75%, right? And right, so split 25% and 75%, right? Roughly again. not exact, right? So let's take a look at our data frames. So we have line first. That's four data frame df. We can do df right like this. Yeah, we can do this like right. And will it work? We didn't do, oh yeah, we use this also temporary, right? It's data frame, right? So this is not, you know, I'll use, so maybe my dframe, you know, dframe, right? Something like this. So you're not confused with the previous df. But again, of course, you could use df as well. We could have used df. We could have used df or anything else instead of the frame, right? Okay, but instead, or not installed else, instead. Okay, now we can basically print with zip. Maybe we need also I'll do the zip with index, right? Well, I'll do this zip with index, that one zip with index, zip with index, zip with index, right? Data set on a row, right? So I, right, like this, right? Data frame number I, right, has the frame count rows. Okay, something like that, right? So a simple loop, right? We don't even need the square brackets. We could have skipped the brackets, of course. So let's run it, see how it actually worked. Right? This is regular Scala code. I mean, this part is just regular Scala we used before. Of course, I could use I+1 because it's carrying data frame number 1. Well, numbers, of course, it's arbitrary numbering. So let's say that work. Yes. So 59. And notice again, we got only 18 samples this time, right? So something completely different again. Not again. So that this movement is quite big. So here again, I'm trusting. Well, it looks close enough. But if you do it in maybe I'll open up a Scala REPL, right? Well, proportion, let's do a proportion, right? Let's do a proportion, right? So, well, we need to save it actually. We will need to save this, right, in a buffer, right? Or do a mapping, right? We could do a mapping, right? Counts, right? While the counts would be what? Data frames, right? Frames on map, and basically df to df count, right? Let's see, did I make a mistake? This any, why did I make a mistake? Or d, I'll just do d, whatever, let's see. Is this really confusing? No, what's happening here? Or did I have, oh, like this, right? Okay, I can't type, okay. Yeah, okay. Data set, data d count, okay. Right, so the count, this will basically be array of long integers, right? So we can do proportion, right? So percentage proportion will be one over another one. So proportion line is a percentage proportion is, let's do it here, right? Proportion percentage will be, of course, what? D counts 0. Let's see, so one is we have, of course, percentage 1 or percentage 2, right? Well, actually, let's do this, do the percentages. Let's do it directly, right? We can do it directly, right? Or we can do it later on, right? We can do it here already, right? Let's maybe df count, right? right, times 100, right? That's percentage, right? That looks good enough, right, to me, right? It should work, right? Percentage, d percentages, right? Times 100, that should be percentages, right? Percentages, so line, the percentages. Okay, so print line. D frame, data frame percentages, it should up to 1, right? Let's take a look now. All this extra stuff, this is all Scala code, of course, right? Except, of course, count is for data frames, right? We use that from data frames. So let's take a look at this, what happened. Okay. Oh, well, yeah, I guess it didn't work because why? It's long, right? So we need to do it, of course. So it didn't really work as well as we want. So too low, to double, right? To double, right? So it's 0, 0, right? And this, of course, I'll put them in a parenthesis just in case I messed up something, right? Oh no, and it's double times 100, right? Right, yeah. Course, and then divide by, right, yeah, okay, that will be good. Okay, to double, right, times 100 divide by df count. Okay, because if you go to double, then it will be a percentage. Okay, or also we could use it, maybe don't even need double. Let's see, 100, yeah, 46. It should be good enough. Let's see if you even need double. Let's see if you need double. I put this 100 in the wrong place, right? Oops, I saw. Again, looks like this is going to be a block manager. Again, something I didn't like, right? But the percentage is 27. Okay, it's close enough. Okay, so it should up to, because we don't have the precision, right? But it is, of course, adds up to 100, right? Adds up to 100, right? So, you know, to 1, it actually adds up to 1, right? So, if you don't, if you put something else here, something which does not up to 100, it will normalize them, right? So, we can do this, right? So let's do this alternatively, right? The whole thing, right? If you want to split, right? It will, you need to make a function to get some stats, right? So this almost begs for stats, right? They get stats, def get data frame stats, right? We add in, well, let's take a look. So the frames, right, will be, well, array of, well, I guess we'll use this array of this row. To be precise, right, this is okay. And what's happening here? Data set. Okay, we return, what will return? Array of percentages, array long, let's say array long, array long, right? And we are going to put all this stuff in here, right? So get data frame stats, right? So we're going to split, and we can give data frames and get some stats. So basically all of this D frame in data frames, right? So we need to change this, right? We would do this here. So data frame, right? Basically, right, rows, and we could map the percentage to after split, right? We could do, yes. So data frame split, Yeah, so this will be basically this part here, right? So D frames. Only thing is we need the base, right? Base will be right, our base. We need the of course we could do this complete split on get stats, right? We could do that, right? Just show some stats, right? Maybe make it even that split on stats, right? That would be also a way of doing it, right? So we'll see if this is easier, right? So this just gives some stats, right? Looks good, right? So we can use it basically here, right? Get data frame stats, right? And we give a D frame, the data frames. Yeah, okay, so it will work. So df comes from is our original one, right? So here, right, we can use it. We probably also, this df count would be nice to have df here, right? So we'll give a data frame here. Yeah, and then we pass it here, right? Yeah. Okay. What did I mess up? It's not a data frame. SQL data frame. Okay. How was it? SQL. What's the problem? Oh, what did I do wrong here? Let's take a look. Any. Oh, I can't type maybe? Oh, like this, I guess. Okay, now it works. Yeah. Okay, now it works. So what did I import? Data frame. I imported here, right? This type. Again, I know this type data frame is equal dataset row. It's actually back underneath. It's the same thing. It's a made up type basically. It's a combined type, right? So now everything looks good. We pass in our split. So we can now get some percentages, right? So we can basically do this now. Another split. Well, data frames, D frames 2, right? Let's do 3 to 7, right? And we can do 2 to 3, right? Split. We'll do something like this, right? So if we do this here, so if I do 2 and 3, right? So proportion. So here, so now the proportion should be roughly 2/5 to the first data frame and 3/5 to the second one, right? I think you get the idea how it works, right? Let's get some stats again. So we'll get some stats. Frame stats. We could actually right, get data frame stats, right? So we could do this. Get data frame stats. We give it D frame split df, right? And this is of course for each print line, right? So just check this, right? For each print line, sorry. Print line. Okay, I think you get the idea. I think we're running out of time already. Yeah, okay, so that should be enough for now. Okay, so yes, what did I split here? Did I split correctly? So 40, 26, 73. So yeah, it looks roughly, it looks very close. Looks close. So 40% to almost roughly 60%. Of course, I didn't do rounding up, but yes, certainly looks like it worked on a second. Again, so this 2, 3. So it is again. So this is normalized to 0.4. So random split will normalize 2 and 2, 3 to 0.4, 0.6, right? Which is actually, so I hope it makes sense. Okay, so your exercise. So what do I want to do? Well, first of course I want you to open up, let's see, open up 2014. Do open up 2014 summary JSON, right, file, and I want to do, what do I want to do, right? I want you to let's see, I want some splits. I want a split, I want a sample, I want a random sample of roughly 30%, right? You can use a fixed seed if you want. That's one. And also I want the split of let's see, of 3. Let's do that. It should be of 3 split of full data frame, of full 2040 data frame into 3 data frames, right? With the following proportions, right? So 2, 9 and 5, right? Let's take a look at how that works, right? So 2, 9, 5, right? So, and I want to split, I want to see the row count and percentages, right? Row count for these data frames and percentages also, right? So I also want the count. Okay, so pretty simple instructions. I think you can do this. Is there anything else I want you to do? We did select. We also, oh yeah, we want also filter, right? Oh yes, we want to, before that, also filtering up. First, filter only flights from US that go at were more that happened more than 10 times, right? From US that happened more than 10 times. So let's separate. That's one task. Task 1. That's one. And then task. This is separate task. Task 2. Task 2. And this is to do task 3. No, yeah, that's part subtask, right? So subtask, I want to see the actual count, actual count and actual row count, right? Sample from all 2014, right? So again, 6 second, right? So let's take a look. It'll be interesting to see, and I'll see you then on at 9 o'clock. Thank you.